Hi everyone, we are Silcotek Team 1, and over the semester we developed a star gear flange sealing device. Silcotek is a world-leading provider of inert surface coatings for industry applications, including lab and instrumentation performance, semiconductor manufacturing, refineries, and automotive reliability. Images of the flange can be seen in the bottom right corner of this slide. We had three main project objectives. First was to optimize labor time by decreasing the amount of supervised flange tightening time below the current 6 minutes it takes to seal one flange. Second, tighten each of the 15 bolts consistently to 27 foot-pounds. And lastly, we want to consider safety concerns such as noise protection and ergonomics.
For prototyping, the elements shown in this slide depict the multiple concepts that went into our final design. We settled on a star pattern gear train to efficiently tighten multiple bolts at once. For the shaft connections to the bolts, or the driven gears, we machined a round steel gear shaft to fit a 6-point socket that would connect onto the bolt head. The driving shaft has a hex head welded on top for ease of connection to the torque gun. The gear train itself is set up to fit the diameter of the bolt circle of the flange. The torque gun used to drive the gear train has an upper torque limit of 200 foot-pounds. With 5 arms, a gear ratio of 1 was needed. The final design to account for the desired torque on each bolt was a 4-inch, 2-inch, 4-inch gear train. Another component included in the final design was an aluminum frame that holds the gears in place and helps protect the operator from injury. Our final assembly is shown on the right of the slide and includes all the components discussed.
The final design is composed of 5 steel gear arms, all driven by the main driving shaft at center gear. The gears are connected through the aluminum disc via a shaft to reach the bolts. The old process to tighten the bolts was to deliver torque in a star-like pattern, going 1 bolt at a time, delivering torque in 3 increments of 7, 17, and 27 foot-pounds. Top right picture shows the old method process that would take around 6 minutes to complete, and Silcotek would complete about 20 coatings per day. The final design delivers torque to 5 bolts simultaneously, as seen in the video. With this, the device would need to be rotated 3 times in order to tighten all the bolts, and then 2 additional times to ensure that no slippage occurred during the first 2 tightenings. The total torque gun reps would be reduced from 25 to 5. This design will reduce the time by about 40% from 6 minutes to about 3 minutes and 40 seconds. This would allow for approximately 12 more coatings throughout the day. From testing, we learned that orientation is critical to delivering the exact equal amount of torque to each bolt. This is critical so that all bolts can be tightened to the correct torque value. To solve this orientation problem, we suggested that Silcotek consider using 12-point sockets on the prototype instead of the 6-point sockets. This would help with lining up the orientation of the sockets with the bolt head from prior hand tightening. Additionally, suggested for future modifications, the disc could be cut out more to reduce weight, and a gearbox cover could be added for more safety protection.